Morning, everyone. In this cold morning, we should be able to start in another 3 or so minutes as we wait for more members to join the session. Today is going to be exciting, so let's just give them a few more minutes before we start. Thank you. Morning, everyone. Once again, thank you for finding time again to join this session, which is a continuation again of the course in emerging technologies. You'll excuse me today, I'm a bit under the weather. I think it's too cold, but should be able to continue normally. When you talk of automation and robotics, there's a lot that we can talk about, ranging all the way from industrial automation, industrial robotics, AI powered automation and robotics, and so many more things. So considering the time that we have, we will lay special emphasis on automation and robotics that touches on artificial intelligence and emerging technologies. And you'll be able to see that in as much as robotics and automation are not new, we can consider them as emerging technologies from the point of how the existing technologies have been transformed by artificial intelligence and computing in general. So when you talk of automation, what do we usually mean? Automation is essentially enabling systems to be able to be automatically controlled. That is automation, or to perform tasks. And is the use of various control systems that can be used to operate equipment or even manage process flow with minimum or reduced human intervention. So when something is automated, there should be as much or as less intervention as possible from humans. That does not mean that a system that is automated cannot receive human intervention, because there are various levels of automation, as we'll see, especially when it comes to autonomous vehicles. Traditionally, as I've mentioned, automation is not something new. It's been there for a very long time, and includes mechanical, hydraulic, software, pneumatic, that is air powered or pressure powered, electrical, and also electronic devices, which include computers, can be used to automate. Now, these are often sometimes combined. For example, you might have a mechanical automated system that is controlled or managed by computer software. So they can be mixed, or you can have an electrical control system, which is controlled or managed by computer software. A good example would be programmable logic controllers, which are mostly used in manufacturing. So when you go to, I'm sure most of you having maybe schooled in Kenya, there were school trips that we made maybe to manufacturing plants or processing plants, maybe like Coca-Cola or KCC or Bidco, one of those companies, or Unga Group. So majority of what happens in the factory floors of those examples I've mentioned is usually electrical automation powered by programmable logic controllers. That is a very, I would say, traditional field. It's been there for many years, and it's helped automate the factory floor to levels that we had thought unimaginable before. And the fact that these controllers are programmable, it means they can be adjusted to suit the existing automation process, or to suit the existing or the upcoming systems. I'll give you an example. Let's say, for example, there's a soda bottle filling plant, and this plant fills the soda bottles, labels them, and makes sure that all the parameters that are being monitored are carefully monitored. And this is done at very high speed. Then one day the organization decides we are going to move from a 500 millimeter soda bottle to 425 millimeter soda bottle. That happened like last year but one. Coca-Cola did that. So what they saw, instead of raising the price of a plastic soda bottle from 50 shillings to 60 shillings due to the increase in operating costs, they decided, let us reduce the size of the soda bottle so that the price remains at 50 shillings. That is a very easy commercial and marketing decision to make, and say, let us maintain the 50 shillings because it's very hard for people to pay 60 shillings due to the coin on top, or even getting change. So let's make it easier by reducing the soda size from 500 ml, the plastic bottle, to 425. And this decision is often forwarded to the engineers to implement. And for that to happen, a lot has to happen, including changing the mold of the bottle, maybe if the molding is done in the factory. Changing how much soda is poured into the bottle, because now initially it was 500 ml, now we need to pour 425. How do we adjust the system to be able to do that? Considering now we are filling less soda into the bottles, it means the conveyor belt has to move slightly faster compared to before, because initially to fill 500 ml would take maybe X number of seconds. To fill 425 would take slightly less. So an entire system had to be reprogrammed to ensure that that is achieved. So that is an example of programmable logic, where the business requirements are transformed into software, which then controls the operations of the system. Now, when you say something is automatic, we could either mean how it works, that is the function of the thing, or how the item operates, or maybe a process. So something is automatic when that system, under specified conditions, functions without intervention by a human operator. And that under specified conditions is very important, because when you're automating for specific conditions. And you try and play out the scenarios to ensure that your automation actually works. A good example is when it comes to automating motor vehicles to have them self-driving. The vehicles will be driving in streets that maybe they've never driven before, in streets that data is scarce, maybe if it's not been mapped properly. But the automation is done in such a way that this vehicle is able to operate well in such conditions, by ensuring that the basics that we need to ensure that automation happens have been captured. A good example is, I gave an example the other day of how a local Kenyan company is training automotive AIs for organizations such as General Motors, BMW, the Volkswagen Group, and many others. And they do this by getting as many pictures as possible of a variety of streets globally, and labeling. Yesterday we talked about machine learning and training, that AI is easily trained with labeled data. So somebody takes a picture and indicates this is a stop sign and labels it as a stop sign. This is a center line, and because it's yellow, it means this is a two-way street. This is another, maybe this is a traffic light, or this is a building, this is a dustbin, this is a trailer, this is a zebra crossing, etc, etc. So we try to ensure that the specific conditions that this vehicle will operate in, that is in an ordinary street, are captured. And by that, we're able to ensure that this vehicle will operate accident-free, or as expected. Now, the other thing that we need to note is that automation, being old, has continued to advance, and it's matured to a point where other technologies have actually sprung out of it, and one of them is robotics. Yeah, robotics is a subset of what I would classify as automation technology, and robotics is essentially a specialized form of automation, where the automated machine, in this case, which is sometimes physical or sometimes virtual in terms of software, possesses certain anthropomorphic or human-like characteristics. Yeah, And this could either be in terms of the intelligence, like it is human-like characteristic to think and logically and make decisions, or it could be physical, and it could be physical appearance. And this is what most people refer as robots, where something looks like an android. Actually, the term android is not the software that runs in phones. The original term android actually means human-like characteristics with arms, legs, and something that looks like a head and eyes. That is called an android. So because that term has now been appropriated by Google for their phone operating system, people also use humanoid robots to refer to the physical appearance of some robots. Yeah. There could be several reasons why robots need to be humanoid, especially robots that serve people need to be humanoid. Like in Japan, you have robots that serve the homes of the elderly, or serving in a restaurant as waiters. That's already available in Japan. So it was found through research that humanoid robots elicit different responses from human beings when they interact with them compared to, let's say, non-humanoid robot. So an elderly person being served by a robot would be more comfortable, or would even want to interact with a humanoid robot more than some device that has no shape or form and doesn't resemble a human being. When it comes also to humanoid robots, there are several issues that are still being addressed. One of them is in terms of our reaction to very realistic and humanoid robots. The reason why most of the robots look like robots, and there is very little effort towards trying to make these robots. I'm not saying, okay, let me not say that there's very little effort, but there is no rush or emphasis in trying to make robots extremely human-like. And this is because as human beings, innately we react in a way when we see non-living human-like beings that closely resemble us. I give you an example. That feeling you get when you see, sorry if it might upset you, but that feeling you get when you see a dead body, or that feeling that you get when you are in a supermarket and you walk next to some mannequins. Some people get that feeling, some people don't get it. You feel an odd feeling. That feeling is called the valley of the uncanny. And it's actually something that was researched by some Japanese researcher. So when people fall into the valley of the uncanny, they develop a repulsive feeling towards the object that is uncanny. Actually, that's where the word uncanny resemblance comes from. That something is uncanny means it is strikingly very similar to what your humans look like. So when somebody says uncanny resemblance, that's what they mean. So when human emotions fall into the valley of the uncanny, then there are challenges there in terms of interacting with robots. So physical robots, in as much as they might have arms, they might have legs, there shouldn't be much effort in trying to make them look like humans, to the point that we cannot tell them apart. Now, having said that, robots are often used to automate what are known as the 3Ds, jobs that are either dull, and a job can be dull if it's very repetitive. You're doing the same thing over and over and over again. Jobs that are dirty. And by dirty, I don't mean just physical dirt. It could mean radioactive dirt. Considering a robot can withstand radioactivity better than humans. So dirty jobs. We saw how Japan utilized robots in the cleanup of the Fukushima power plant, where it was very dangerous for human beings to go in and carry out that job. And robots were able to be deployed and do surveys and carry out some tasks and enable the power plant to be secured from damaging the environment further. Yeah. And it can also be used for dangerous processes or activities like that one. That example that I've mentioned is also dangerous, other than being radioactively dirty and physically dirty. Dangerous activities could mean maybe rescue in places where during earthquakes or where these buildings have collapsed, or even during fires, though that is something that is still being worked on. But then, as we discuss robotics, we are not going to spend a lot of time discussing humanoid robots or industrial robots. We are going to specifically focus in an area that is of interest, especially to you, and which is the autonomous vehicles or connected vehicles. So what would be the difference between the two, an autonomous vehicle and a connected vehicle? We will see that. But automation has come a long way, and it's seen a surge in use, especially in the internet age. Majority of the things that are done online are actually automated. Many of the things that we do, for example, when you're interacting on social media and you post a picture of your friend or of yourself and maybe and your family, and automatically Facebook recognizes those faces. That is a form of automation. Or there are also business process automation, which are also known as robotic process automation. We'll see some examples there, and we'll be mostly focusing on that type of automation and vehicular automation and robotics, due to the fact that we can talk a lot about industrial robotics and a lot about other forms of physical robotics that might not really drive the point home in this session. And automation has been there. We've had algorithms and scripts that have been used to automate, but now that is now being advanced further and is being accelerated by advances in machine AI, which have brought in a new paradigm in as far as what automation is, because initially automation used to be made up of rules, where you do this, then that. If this fails, then do that. But with machine learning, we automate and set boundaries only, and then the system internally learns and continues to learn and becomes better at what it does. And we'll see some examples in that. I mentioned about robotic process automation. This, I believe, is one of the most common forms of automation that people know of or have used. You might not have known that you're using an RPA system, but RPA is essentially the use of specialized computer programs known as software robots to automate and standardize repeatable business processes. So something that is repeatable, a business process that is repeatable and is done daily. For example, let's say the monthly generation of invoices to customers. That is repeatable, and there are rules around that. We can set rules and say, rule number 1 for invoicing is this, then this, then this. Then maybe generate the invoice in PDF, then maybe email the PDF to customer, and you receive an automated invoice from your provider or supplier. Now, why has RPA attracted a lot of attention of late? Number 1, as I've said, is machine learning and artificial intelligence. That's the key area. A lot of processes in organizations these days are automated, and businesses are gaining significant leverage in that front, because things that human beings used to do previously. For example, as we near month end, in most organizations, the billing or accounts receivables teams are usually very busy generating invoices for customers, counter checking, and all manner of control and process happens. That is labor intensive, time consuming, and fraught with errors. So with RPA, we can streamline operations in a business. And because of that, the reduction in errors, the failure to use human beings ends up reducing costs significantly. And costs can also be significantly reduced because you can utilize, as we saw when you're doing cloud computing, excess capacity in your environment, in your cloud environment. We also saw that you can actually, on the cloud, maybe get compute services that are known as support services. These are the services that are available from other users who have bought this service, but they are not using them at that time. So some of that compute power can be availed to you at a much lower price compared to maybe you running your own independent server to do that work. So RPA can be combined with spot instances on the cloud to significantly lower computing costs. For example, something like invoice generation, it doesn't have to happen during the day. It can happen over a period of time, maybe between 28th and 30th of that month. So in between that period of time, you can set your cloud computing service in such a way that you buy spot instances or spot capacity that is available from other users to generate your invoice, and you end up paying close to nothing when it comes to that. Something that you'd have previously maybe paid a considerable amount to do under normal computing environments. Yeah. Now, RPA has been used in businesses, and what is happening is that those mundane processes that businesses do are now automated, and the business focuses its energies on high value work or high leverage work. And in some instances, organizations that are deploying RPA are usually either on their way to what is known as intelligent automation, where they say, before we go to intelligent automation, let us first automate what you already have using RPA. Then slowly they build up that system and introduce machine learning and AI tools, and they can be trained to make judgments about future outputs and inputs. Yeah. A good example, an RPA system will be able maybe to just generate invoices for, let's take an RPA system in a service provider environment, in an ISP. So we have 10 customers. Each of these customers is paying us 10,000 shillings. So that's easy to generate, to set up an RPA process to do that on the 28th of every month is very easy. But now, as time goes on, we need to deliver more value to our customers in form of the services we provide them. And one of these values could be, maybe we now want to give service credit notes to customers who faced downtime below the agreed quality of service, or SLA. So out of our 10 customers, we could have 2 customers who had a downtime, and we need to reimburse them. Maybe one of them needs to be reimbursed 2,000 bob, the other 1,000 bob. Now, having a traditional RPA system do that would be a bit problematic, and that is where now AI and machine learning comes in to provide what is known as intelligent automation. So this invoice system that has RPA, with the addition of machine learning and AI tools, we can now be able maybe to have this system query the network monitoring system and see, out of our 10 customers, what were their availabilities, and make calculations and judgments in terms of, based on these availabilities, did any of these customers qualify for a credit note or for service rebates? and a decision can be made by AI. And in future, such a system can even continue to learn and know that if we issue, for example, rebates above this percentage, then we need to take the following steps or notify the following people or whatever decision that needs to be made. Yeah. So this is what is currently happening. Many businesses are deploying robotic process automation. And again, as I've said, robotic traditionally meant humanoid robots with arms walking around, Terminator type of robots. But an algorithm is a robot. I'm sure most of you have seen in web pages where you have to click somewhere and say, "I'm not a robot." Why is it that you are asked that? And we'll see why that happens. And it's actually one of the ways to prevent abuse of automated processes. Actually, it's here. So you can see that when in most websites, I'm sure most of you have seen this, where you have to click here and say, "I'm not a robot," and then you are able to now to proceed and use the system. Or in some instances, you're given an image like this, and you're told to, maybe in this case, select all the squares with traffic lights. Then you select them. In this case, it would be this one and this one, these two here, and maybe that one. In some instances, this might say, select all the squares with the vehicles, or select all the squares with the vehicles that are not SUVs. Yeah, something like that. Or select all the squares with bicycles or pedestrians. So this is actually a way, and it's called CAPTCHA. CAPTCHA stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart. So anyway, you've seen CAPTCHA. I'm sure when you're clicking this, "I'm not a robot," there's usually this 3 arrows here, and it's written there, CAPTCHA. Yeah. So CAPTCHA actually means that. And this is basically a Turing test. And a Turing test is a test that can tell a computer and human apart. And one of the ways in which it was actually coined by Alan Turing. You should read about Alan Turing, one of the pioneers of computing. One of the ways in which we classify AI or test AI systems ability to perform like humans is the use of Turing tests. Yeah. So far, many of them have not been able to pass the Turing tests, and the race towards making AI more intelligent is actually the race towards making computers pass the Turing test. So in this case, you wonder, how does just clicking here, "I'm not a robot," do? Yeah. There's a lot that we can discuss about how. One of them is how your mouse moves to come and click there. In an automated system, for example, that is designed to actually move this cursor and click, the CAPTCHA system will tell that was not a human being moving that mouse. Because as a human being moving this mouse, there's no way I can move this mouse straight on a straight line of pixels across this screen. It's impossible, because this screen, remember, is made up of very many tiny pixels arranged in straight lines. So as a human being, based on my dexterity, I cannot move that straight. Yeah. So that already tells the system that as I move my mouse to click here, that was not a software doing it. That was a human being, and it's very easy. And in this case, for example, this picture that says select all the squares with traffic lights. Yes, as a human being, I can tell this is a traffic light because I've seen them somewhere. Yeah. And I am looking at this image as one image, but ideally in the background, these are separate images according to the computers. Yeah. So in as much as I am able to see there's that traffic light there, then it extends all the way to this one. So I can select this square, that square, and that square. And I know that these three squares constitute the traffic lights. Yeah. But when the computer algorithms is analyzing these images, this square, this third square at the top here, from third square from the left, this one here, if you analyze this image independently, there's no traffic light there. It's just a street lamp and some black mark just down the image. But a robot would not know, an AI robot would not know that this is part of the traffic light. Same for this square, which has the front part of this car and the back part of this car. Yeah, it's unable to clearly tell that this is a, if I'm selecting, if I'm told select the squares with cars, I would select that, and maybe that. Yeah. This is where the crux of the matter is. This lower left box, because you see that wheel there. This image analyzed alone, there's no car there. Same for this image here. So it could be anything, and it could be pedestrians maybe walking here. I told select the ones with pedestrians, and then there's one where the pedestrian's arm, only the arm extends to the next square. So you know that that is a pedestrian there, but the robot won't know. That is a way in which we can prevent misuse of algorithms and robotic process automation. Why do we need to do this? I'll give you an example. Let's say you run a service to have people send mail. For example, let's say you run an email service like Gmail, yeah, and you want that this system should only be used by human beings, not by automated systems and processes. So before a user logs in, you can have them do this test. And if they fail, then it means that was an automated script trying to do it. Because what is happening now is that especially hackers or people who are trying to utilize other people's computing resources usually write scripts that can automate some of these things. For example, if I'm a spammer, I can't sit down and send all those rich Nigerian uncle has died emails seated down. There'll be too many. So I write a script that will log into maybe an email service and automatically send all these spam mails. But that script won't be able to log into that email service if there is captcha on that email service. Or if maybe there is another way. Captcha is one of the ways, and it's the most popular way. But if I'm running a system and a service, I would want to prevent it from being abused by other users, either online or within the organization, who might maybe automate some of the processes on their side to utilize my system. For example, if I'm running a large database of photos, and I do not want people to write scripts and search this database for particular types of photos, I can implement captcha to stop scripts from connecting to my processes. That's one way. And the reason why you're saying I'm not a robot here is not because you were expected to be a robot or anything. What you're simply saying is that I'm not an automatic script that has been written by someone to connect to your system, which could potentially lead to the abuse of your system. Because maybe whereas I can allow you to do that, you might establish 5,000 connections at once to my server and maybe crash it. Yeah. Such systems can also be used, as I said, by hackers. Because if your system is unprotected and I can connect my script to it and maybe run processes, maybe run queries to it, I can bring down your system by writing software that can establish very many connections to your system and bring it down, or can make very large queries that can overload your system in terms of processing, and so on and so forth. So that is one area which this is one way in which we can prevent that from happening. The question that usually comes then, why do we need to automate? And the answers are very obvious. Of course, the first one is to increase throughput or productivity. The second one is increase quality, and this could also mean increase predictability of quality, because now this process is automated by certain rules. It is not being done by humans. And of course, that brings in the consistency of following the processes, yeah, which again improves robustness. You are sure that this process is foolproof because it's not Tom who has had a bad morning today following this process. It's not Jen who had a quarrel with his house help this morning while leaving for work that is following this process. But it's a robot that will not make any errors, yeah? So the consistency is very key. And then the other obvious thing which organizations really love is reduce direct human labor cost and expenses. If we can automate invoicing, then by default, we might not need a billing accountant, yeah? Or if we had 10, we might need only 2 now instead of the 10. And when it comes to automation of systems that can harm us, automation ensures that safety is drastically improved. And we've seen instances where systems that are automated also have algorithms to handle exceptions. Exceptions to the rule, how are they handled? For example, does the system auto shut down? Does it reduce certain key parameters, etc.? And then, of course, if we automate some of these processes, then we can free up some of our staff to focus on more productive tasks. That billing accountant could do something else more productive within the organization. For example, sell, or maybe offer customer service, yeah? Or do something else that is more productive than just generating invoices from a system. Now, I'd like us to look at an example of robotic process automation. This is a video by KPMG. And KPMG is an accounting firm. So why is it talking about robotics? It's because RPA is becoming very attractive, and it's I would say it's one of the buzzwords these days when it comes to process automation. Everyone who does process engineering is talking about RPA and how it can transform the organization and all that. So let's see a video from KPMG on how RPA works. Can you let me know if it doesn't have sound?
This demo shows how an RPA tool works. RPA can be applied for the automation of transactional rules-based tasks, where structured data and clear predefined rules and parameters are used. The solutions are easily and quickly designed, tested, and implemented. They are designed to require relatively low investment or expenditure. This demo shows how a process such as the creation of invoices is executed by an RPA tool. You will see how routine activities can be easily performed by the RPA tool based on predefined rules. The RPA tool used in this demo is Blue Prism. The key steps for the creation of invoices are as follows. In this process, The invoice request is received and opened, relevant data is entered into SAP, and the invoice document is created. At the beginning of the process, the software robot opens the correct environment in SAP and logs in. An invoice request is received by the software robot via email. The robot opens the email and the attached Excel template and scans this thoroughly. Different checks are performed by the robot to determine whether the data from the Excel template is of a certain quality. The software robot runs the transaction code for the creation of invoices in SAP. Subsequently, the invoice data from the Excel template is copied and pasted into the relevant fields in SAP. The robot recognizes if essential information is missing in the invoice request. If this is the case, the robot sends an email to the invoice requester with a request to adjust the specific invoice data. When all the data is entered in SAP, the robot creates the invoice by running the correct transactions. The invoice is then correctly saved for sending. At the end of the process, the robot sends an email to the requester with confirmation that the invoice has been created and moves the invoice request to the relevant subfolder in Outlook. Additionally, all the used applications are correctly closed. You just saw an example of how robotics can be deployed for a finance process. Next to the finance processes, there are many other opportunities for RPA that exist across other functions within the organization. Examples of these include customer care, business operations, IT, and HR. So, are you on the road to robotic automation? Success here isn't about if, but when. Now is the time to get started.
So this is an example, a very good example of how RPA is being used in organizations. As I mentioned, one of the things that we need to cover today is as concerns transport automation because of its interest in especially the target audience for this course. We have looked at business automation and how AI and RPA can be used. That has just barely scratched the surface. We can talk a lot about that, but our focus today, I'd like us to put some more emphasis and time on transport automation. And the first question that usually comes is, why do we need to automate transport? Is there a problem? Of course, there's a big problem. Globally, we have, in 2018, this is data for 2018, we had about 1.5 million people killed in road traffic accidents. And in these road traffic accidents, it is estimated that over 90% of the causes of these accidents are because of human error. So human error is responsible for majority of the accidents, either somebody getting distracted, somebody making the wrong decision, or two drivers making the same decision, yeah, and end up crashing. So in instances where maybe two drivers make a decision and end up causing an accident, for example, if there's an oncoming car ahead of you and you decide to swerve on the right, and the oncoming car decides to swerve on the left, it's left. So both of you won't have swerved away from each other and end up crashing. So how does transport automation and connected vehicles prevent that? Yeah, if these two vehicles were connected or communicating to each other, then such a simple error can be avoided. Yeah. Or you make a decision based as a driver based on what you see, and you are unable to see some blind spots, which maybe the vehicle can see. Or an oncoming vehicle can be able to notice that you are about to get into the highway and you've not seen it. And if the two vehicles are communicating, then an accident can be avoided. Out of majority of the accidents, especially the ones that I've seen in Kenya, other than overspeeding and reckless driving, majority of the accidents are caused by people who are often joining the highway. Yeah, who are often joining the highway. So most of the crashes are usually maybe a motorcycle trying to join the highway, and then another vehicle is overtaking on the other lane, which wasn't expected, and all that. The other thing is, in terms of transportation challenges, there has been very many man-hours wasted in traffic because traffic is uncoordinated. Each and every unit on the transport network is operating independently. There's been a lot of research in that, especially you can read about swarm networks and swarming, what swarming is, so that we need to move transportation from vehicles being independent units on the road and make them function like a swarm. You see the way a swarm of bees moves around in unison, in agreement, as in well coordinated. So you can imagine if all the vehicles in Nairobi behaved like a swarm, there would be absolutely very little traffic jam. So there's a lot of commute time being wasted. There are various reports that have been released in Kenya on how much Kenya spends every day on traffic jams. Some figures say 50 million shillings, some figures say 80 million, so I'm not sure which is which, but I want to believe the 50 million one because it's from Kenya National Bureau of Statistics. So that is a lot of money. Every day, Nairobians waste 50 million shillings in traffic, either in terms of fuel spent, either in terms of their time, time that could have been productive elsewhere. So why transport automation would really help here is because if I'm in traffic and I'm in the car, I have to operate that car. If I'm seated in traffic and I'm wasting time there, just sitting there waiting for the car ahead of me to move. If I was in an autonomous vehicle, I could be working. I could be responding to emails, I could be writing reports, I could be holding meetings while the vehicle is in traffic, yeah. Then of course, the other obvious thing is the environmental effects of vehicles due to them just driving around and also due to traffic jams. We saw the other day when there was the lockdown, the partial lockdown in Nairobi started. Within 2 weeks, the sky had cleared. People could see Mount Kilimanjaro from Nairobi, from the southern bypass. Some people could see Mount Kenya from Westlands, all the way in Nyeri, and many other things. And the city skyline became clearer. And those are just 2 weeks of people not going to the office. So the environmental effect of vehicle is something that is of concern and is one of the transportation challenges, yeah? And all this, all these things that we've mentioned above, if solved in one way, either directly or indirectly, working towards meeting some of the SDGs that we saw in day one. If people are more productive, then of course they can earn more. If the environment is safer and cleaner, then of course the life expectancy improves. It is estimated that living in Mumbai, due to the pollution, is equivalent to smoking 20 cigarettes a day. Imagine that. It's equivalent to smoking cigarettes, just living in that city. So the life expectancy of human beings can greatly be improved if we solve some of these challenges. Also in terms of accidents. Accidents rob families of breadwinners, and we've seen families where the breadwinner dies due to an accident and that family is never the same again. maybe those kids never get an education, maybe their financial fortunes change, and many other things, yeah? Or somebody is maimed or crippled for life due to an accident, and that person becomes less productive and maybe sickly. So transportation challenges today are one of the major issues that we need to resolve. Even in Kenya here, people call it the matatu menace, but it's not really the matatu menace, it's our menace, because I have never seen people in a matatu that is overlapping. Stanley won the driver. Wait, what's up overlap? People are always happy that they're going to work faster. So we are all part of this. And these challenges can be resolved by automating transport. And I gave examples the other day how NTSA, for example, can use Internet of Things, artificial intelligence, to be able to carry out its mandate very well, yeah, which we won't repeat here. But there's a lot, and when it comes to transport automation, we can either talk of connected vehicles or autonomous vehicles. What is the difference? In a connected vehicle, the vehicles are able to communicate with each other and also the world around them. A vehicle can communicate to another vehicle, a vehicle can communicate to street lights, can communicate to say traffic lights and all that. How would a vehicle communicating to street lights really help? There are many ways, because number one, if it's a rarely used street and it's illuminated, those lights do not need to be on throughout just for vehicles to pass. The system can be designed in such a way that where the vehicle is, maybe the 4 street lights ahead light up immediately the vehicle reaches that point. And as the vehicle moves, the street lights ahead keep on lighting up while the ones that the vehicle has already passed switch off. So you can see where that's going. There'll be immense benefits derived from that, because we will conserve power. We'll also increase the lifespan of these street light systems, yeah? And if a vehicle is moving, for example, very fast in a isolated street and it's lit up, only the sections where the vehicle is passing will be lit up. And this can be done by the vehicle communicating to these street lights and saying, I'm about to arrive there. And based on my speed, I need maybe the 5 street lights ahead of me to light, or maybe 2, because maybe I'm moving slow. Or if I'm driving like a maniac, maybe the 10 streetlights ahead of me need to light up. And as I pass them, the ones behind me switch off to conserve power, and the ones ahead keep on lighting, yeah? So that is one way. Now, that essentially means that when you talk about connected vehicles, it's yes, Haji?
Good morning.
Morning, Haji.
Today I'm also a bit under the weather. I can't speak louder. There's an SDG on smart cities.
Yes.
Where I know connected vehicles and road transport automations are not just in cities, all over the country.
Yes.
But if we sort out cities, make them smart, like this, if you are to do what is autonomous vehicles, it's not possible in Nairobi because 90% of traffic lights are overridden by police or don't even work.
Yes.
I think there is a foundation that we miss on that SDG of making our cities smart.
Yes, I was actually to touch on that in this session, but maybe let me just expound on that after this slide.
Okay.
So when we talk of connected vehicles, it's essentially supplying the information to either the driver and to help the driver make more informed decisions, yeah? And in most instances, when we talk about connected vehicles, we don't necessarily imply that the vehicle is making most of these decisions for the driver, yeah? And often it supplies these decisions, supplies this information to the driver, and the driver makes the decision. This has now also advanced to a level where this information being supplied to this vehicle, these vehicles are now able to make decisions on behalf of the driver in instances where it's a matter of life and death. For example, if the information shows that a crash will happen if the driver doesn't take action, the vehicle will be faster to take that action than the driver, yeah? Maybe just to answer your question, Haji, when you talk of smart cities, you are right that maybe Kenya is a bit chaotic. Even when you talk of autonomous vehicle, these autonomous vehicles maybe do things like looking for lanes, the road markings, looking for road signs and all that. Most of these in Kenya are vandalized or they are not well maintained. There was a time when on Mombasa Road, the county government did its own road markings. Then 3 weeks later, Kenya came and did its own lane markings, which were like 5 to 10 centimeters next. Yeah, so there were two lane markings in the middle of the road. And that will cause confusion. Most of the roads in Kenya, for example, are not marked. And it poses a challenge to, for example, automated or driverless cars. Yes, Titus?
I just wanted to add to what you were saying.
Yes.
On the connected vehicles, I think the Subarus from Japan already not have that technology, whereby if you are too close to the vehicle ahead, they automatically brake.
Yes.
So it's already happening. I think they have infrared cameras or some kind of things like that.
That's actually a normal camera. For Subaru, they call it Subaru eyesight technology. But you see, that is different because that vehicle, that Subaru, is not connected to the next vehicle. This is a decision that is made by the vehicle itself based on the parameters it's observing. So there's a slight difference there. When you talk of connected vehicles, we are talking more than just maybe braking because there's an obstacle in front. There's a lot of info, as we'll see during the presentation. There's a video we'll watch of a Tesla, what a Tesla sees. Forget about what the human being seated in the Tesla sees. We'll see a video of what a Tesla vehicle sees on the road and how it makes decisions, and that will be very interesting. To continue answering Haji's question, there's a lot that needs to be done, especially in Kenya, in terms of preparing our infrastructure for connected vehicles. And that is where now government bodies come in. It will be more of a multi-sectoral approach, not just the road institutions like Kenya or Kura. It would involve even the CA, it would involve NTSA, it would involve advertising agencies, county governments, and all that. Because to give an example, how do we ensure, for example, all our roads are marked correctly, all the road signs are there and they are not vandalized? How do we ensure that manhole covers are not stolen? Yeah, because a vehicle doing lane keeping based on the lane markings might assume that the road is smooth, and then maybe there's a sudden pothole that was caused by stolen manhole covers. That is very common in Nairobi estates. And smart cities is not just about transportation. It covers areas to do with water, for example, automatic water billing, water supply, waste management, areas to do with health and pollution monitoring and all that. So it is an entirely encompassing field, which could actually be a very interesting topic to cover on its own in terms of smart cities. We can actually see how to cover smart cities as an entire session, maybe before Friday, if you allow me, Haji. And in that, we'll be able to discuss what a smart city is and how AI, artificial intelligence, machine learning, IoT, telecom connectivity, either wireless, etc., how that will power smart cities. One of the main reasons, as I mentioned last time, why 5G is being developed is in the area of not just enabling faster internet speeds, but connecting very many devices. We saw that LTE can do 100,000 devices per square kilometer. 5G can do 1 million. So that is a 10-fold jump in terms of the capacity to connect devices. And smart cities are ideal, but not easy to achieve, especially with cities that have historical infrastructure challenges such as ours. Yeah, it would be very easy, for example, to achieve in a city like London or one of these first world cities, or in Johannesburg, for example, but a bit tricky to achieve here. So there's a lot that needs to be done first before we get there. The challenge of smart cities isn't even the connecting of these systems together. It is interpreting that data in real time and mass. That is where the challenge comes in. Yeah. So, so what you can do, we can have a session on smart cities where we will cover all that, Haji, and everyone else, so that we continue on this one.
It's okay.
Okay. Now, the difference between connected vehicles and autonomous vehicles is that an autonomous vehicle is driverless, yeah, or one that can operate for a considerable long period of time without human intervention, yeah. And these vehicles use systems, we'll look at those systems next, that allow the vehicle to see the environment or to sense the environment around it. See might be the wrong word, but sense the environment around it, form a virtual image of the environment around it, and with that image, make driving decisions. Same way a human being drives. When you're driving, you're looking around, seeing, is that guy about to join my lane? Or is this vehicle ahead about to stop? Or is that pedestrian about to cross the road? Or is that a wall that I should avoid or something? Or is that a roadblock? So all those decisions are made by humans, can also be made by vehicle, autonomous vehicles. And the vehicle will need to respond to these conditions effectively and in a way that will enable the vehicle to navigate across safely. So the key issue is safety in autonomous vehicles. One of the main drives towards autonomous vehicle is actually safety. Because as we've seen, 90% of the accidents, over 90% of the accidents are caused by human error. So we are simply trying to remove humans from the equation as far as driving is concerned. Again, when you talk of automation, it's not just black and white. Yeah, there's various levels of automation. And the Society of Automotive Engineers, SAE, I'm sure you've seen this SAE somewhere when you're changing oil. the oil container written SAE 50W40 something or 20W5. That's the Society of Automation, Society of Automotive Engineers. So this society came up with the levels of automation that range from 0 to 5, so 6 levels. And of course, level 0 means there is absolutely no automation and the vehicle has no autonomy and the driver performs all the tasks. This is majority of cars like in Kenya or in the world actually. The drivers are the ones performing majority of the tasks. Level 1, the vehicle is controlled by the driver, but there are some driver assist features, like the one that you mentioned in the modern Subarus. That is a driver assist feature. Yeah, some Mazdas, some Hondas have driver assist features, like start, stop. Majority of cars these days, modern cars, are coming with those features. So that is level 1. So when you are driving that vehicle in Kenyan roads and it's able to use radar to detect the vehicle in front and assist the driver, because assist the driver means maybe the driver is a bit distracted and by the time he steps on the brake, it might be too late. So the vehicle, based on its computer algorithm, is able to know that if this guy does not do what he should do in the next 500 milliseconds, then there'll be a crash. Let me just do it. Liwe liwalo, yeah? So the car will stop. So that is one level. And then the second level, of course, is partial automation, where the vehicle has combined automated functions. For example, cruise control. That is a partial automation. When you are doing cruise control, you don't just do cruise control and start reading the newspaper. You remain in control of the vehicle during that period of time, though the vehicle is able to perform cruise control. And the driver is actually responsible for monitoring the environment. The vehicle will only enhance what the driver wants to do. But in terms of monitoring, that responsibility remains with the driver. And there are some things that might necessitate what is known as conditional automation, which is the third level. And in conditional automation, actually the fourth level, because they start from 0. The driver is there, but is not really required to monitor the environment. And in such instances, the driver must be ready to take control of the vehicle at any time within a short notice. Conditional automation example is the Tesla autopilot. Tesla autopilot is an example of a conditional automation where the vehicle can navigate streets safely. But in instances where it's reached a level where it's unable to make a decision, or you as the driver notice that this vehicle is about to get into a crash, then you make the decision and take control of the vehicle. Now, conditional automation also means that there has to be control and regulation around it. For example, in the US, if you're using Tesla autopilot, in as much as the vehicle is driving itself and can do that maybe for another 50 or 100 kilometers, the driver is not supposed to get out of the driver's seat. In some states, that's the law. The driver maybe is not supposed to do some things. In some states, that maybe the driver might be allowed to do, maybe look at his phone, maybe read the paper a bit. In some states, they are not allowed. You just sit there and look at the road or chat with whoever you're chatting to in the car, but your eyes must remain on the road. So Tesla automation is one example. Then the fifth step is actually high automation, where the vehicle is capable of doing all the driving functions under certain conditions. And the driver may have an option to control the vehicle. So Teslas have now moved from level 3, and the new Teslas that are being released are now moving to level 4. And as you can see, even when you get to the last level, which is full automation, this picture here, this, you see the first one here, the driver is there, holding the steering wheel. In this last one, the steering wheel shape is still there in dotted lines. Yeah, it's not fully eliminated. So in full automation, the vehicle is capable of driving itself, but the driver may have the option to control the vehicle. General Motors, the other day, when they wanted to test their fully automated vehicle, it was a Chevy Bolt, I think. When they wanted to test it, and in the application, they indicated that the vehicle will not have a steering wheel, that application was rejected, because authorities still believe that we've not reached that level where a vehicle can be on a road full of very many other people and the vehicle does not have a steering wheel. We might reach a level where the vehicle does not necessarily need a steering wheel when the adoption of fully automated vehicles becomes the norm rather than the exception. Yeah. So these automation levels are handled or defined differently in different countries. So even, but this is just a recommendation by the Society of Automotive Engineers. The US restricts full automation of a vehicle without the vehicle having the option for the driver taking control of the vehicle. So those futuristic videos you see of people seated in a car, the front seats facing back, facing the back seats, so the people look like they are seated in a meeting as the car drives forward. We are not there yet. We will get there, but we are not there yet. For now, we can have vehicles that can drive themselves across the country, but there must be a way in which this vehicle can be controlled. Yeah. Now, there's a lot of talk. I've said that when you go online, you'll see a lot of futuristic car designs and all that. But how far are we in as far as autonomous driving level 4 is concerned? Yeah. As you can see here, this is the Gartner hype cycle for emerging technologies as of last year, end of last year. So this was released this year, indicating as of end of 2019, where are all these various technologies and what are the timelines? Yeah. Autonomous driving level 4 is here. It's actually in the what is known as a trough of disillusionment. Yeah. On this hype curve, there are various levels. There is innovation trigger, peak inflated expectations, trough of disillusionment, slope of enlightenment, where the technology is now being massively adopted and where it becomes the norm. Yeah, plateau of productivity. So autonomous vehicles driving level 4 is about to exit the trough of disillusionment next and proceed to slope of enlightenment. However, the timelines we're looking at are more than 10 years. So we are not talking of next year we start having autonomous vehicle. There's a lot that needs to be done, especially in third world countries. But again, why are we talking about this now? Yet it's about 10 years to come. 10 years is not a long time, and we might be caught flat-footed if we do not start now preparing for that, because when it comes, it will be big. Yeah? It's going to be very big. The same way we have a Ministry of Roads. Yeah, that is how important infrastructure is to the economy. The Ministry of Roads, in this case, maybe, or even KENHA or whatever body that is given that responsibility, depending on their jurisdiction, has to start preparing now for this level of automation. And this partially answers Haji's question that yes, we are talking about all these technologies and their application in meeting SDGs. But as Kenya, for example, we're in a mess. We can't say our transport infrastructure is there yet. So the fact that this technology is about to start getting used maybe in the next 5 to 10 years, we'll be looking at 5 years maybe in more advanced countries. The 10 years is generally for the whole world, not just the US or UK. We need to prepare now. For example, if we are going to do connected vehicles, what are the regulations around, for example, the SLAs that connectivity providers will give towards vehicles? Yeah. Who is liable when an SLA is not met, maybe in terms of how fast data is shared with the vehicle and an accident happens and losses occur? Is it the connectivity provider for not meeting the SLA? Is it the car manufacturer for having computer code and algorithms that were not very optimal in as far as decision making is concerned? Because that happens. Remember, when a vehicle makes a decision on the road, that decision was made a very long time ago by a software programmer somewhere. Because the computer is running software that was written. In as much as this system is learning and taking action based on what it sees, some decisions that this system makes are actually hard-coded into the system. How do we ensure that we are ready for autonomous driving? Because it's going to be big. Yeah, transportation is a very huge thing. Infrastructure is one of the key pillars that most governments campaign on or show that they've delivered to their citizenry. One of the key measurables is usually infrastructure. So there's need to prepare, even as, for example, Kenha or Kura issues tenders for roads. Same way we have space maybe for street lights, space for traffic lights, space for bikeways or walkways for pedestrians. Maybe we need to consider additional infrastructure next to the road. So that is what we need to look at now, even as the technology matures in as far as adoption is concerned. Now, I'd like us to take a break briefly, maybe for about 5 minutes. Then we can reconvene maybe. It's now 11:35. We can convene at 11:40 if that is okay. So that we continue, we see how autonomous vehicles work and the various systems that they use, and how, as a country or as a regulator, can prepare for autonomous vehicles in terms of the laws, in terms of the regulation, in terms of driver mindset. Remember when Thika Superhighway was opened, you miss a turning and you end up in Thika because people are not used. There had to be some sort of self-drivery education, yeah, which of course happened, but some people still miss it. You miss a turning, maybe exit 8, and you end up in Northeastern because there's no other way to exit. So with the advancement of autonomous vehicles and all that, there is a lot that needs to change in as far as the law, in as far as the training and the approach is concerned, yeah? And that's what we need to look at. So we can take a break and then convene after 5 minutes. Thank you. So we can continue. From where we left off, we wanted to look at how autonomous vehicles work and how this ties into our objective of this session or this course. And basically these vehicles, as we've mentioned, use various tools or sensors to sense their surrounding. And then based on the information received from these tools, create an image of what the surrounding looks like in terms of are there obstacles, are some of these obstacles moving, or in what direction are they moving, how far are these obstacles, etc. These include the use of LiDAR and use of radar, GPS, and the normal cameras that we use, but slightly specialized for this work. The vehicles also use advanced control systems that are software powered. Majority of them actually artificial intelligence driven to interpret the information that they receive from these tools and make or identify appropriate navigation paths. Because a vehicle might be on the road, but then there could be a huge tree branch that has fallen on the road. The decision to move ahead should not be based on the fact that the vehicle is keeping its lane, but the fact that there's an obstacle ahead and the vehicle needs to either swerve and avoid the obstacle or stop. Or if the obstacle is too small, for example, if it's a paper bag that is on the road, then you do not need to swerve, just drive over it, or few leaves or branches, yeah. These vehicles, as we've said, use navigation tools such as maps. Many of them use Google Maps because at least Google Maps is very well updated. But they do not solely depend on Google Maps to make decisions. They combine that plus the data, the sensory data that they receive to make decisions on navigation. If we look at the various technologies that vehicles use, we mentioned LiDAR, which is basically the use of laser lights to detect the environment around. Then there's radar. We'll see what is the difference between the two and why some autonomous vehicle developers such as Tesla does not use LiDAR. Yet majority of the vehicle, autonomous vehicle manufacturers are using LiDAR, and we'll see why. Then we have cameras, and then we have sonar, which is basically like LiDAR and radar, whereas LiDAR uses laser light and radar uses radio waves, sonar uses sound. And then there is also GPS positioning by use of GPS satellites. For your information, GPS is actually is not the technology. This is actually a brand. If you go to Russia and use their system, it's not called GPS. GPS has been used now as a descriptor of location services. In Russia, they are known as glasnost. And the reason why maybe Russia doesn't use GPS is because the GPS system is owned by the US Air Force. And they decided to release it for free to the public for use in navigation to everyone who wants to use it. But by the fact that the system belongs to the US Air Force, of course, that tells you that some governments are not very keen in using GPS as is. Europe is currently launching its own satellites for navigation to compete with GPS and GLaSSNOST, and they are known as Galileo. So soon, I think it's already in operation, if I'm not wrong. They face some difficulties in some of the satellites failing to go to their correct orbital positions, but there's variety. You know, most people think GPS is a technology. GPS is actually specific to the US Air Force, and it's available in most phones. Google Maps uses GPS. In some phones, you have the option to either use GPS or use GLaSSNOST. Soon you'll have the option to use Galileo, depending on your requirements. And then, of course, there is a software, which is mostly artificial intelligence powered. So when you talk of LiDAR, it stands for light detection and ranging, which of course means now radar means radio detection and ranging, while sonar would stand for sound navigation and ranging. Yeah. So LiDAR uses a laser light to create a 3D image of the autonomous vehicle's environment. And this image below is a sample of what an autonomous vehicle sees. Yeah. And this image has been created using LiDAR. So as you can see, these are pretty good reconstruction of what the vehicle sees in front. What you need to notice that LiDAR is 360 degrees. It can see around the entire vehicle, even in the back. So if we were to take a screenshot of what a vehicle using LiDAR sees from the back, it would be an image just like this, but from the back of the vehicle and to the sides also. And the LiDAR is usually positioned on top of the car and using systems that rotate very fast. And it is being hailed by some as the way to go. The only challenge is that it's expensive. A LiDAR detector is a bit expensive, and that is why someone like Elon Musk thinks that the future of autonomous vehicles does not lie in LiDAR. You can read about his comments. They actually generated a lot of discussion online with people wondering, could Elon be right, or is he just speaking his mind without any facts or statistics, which he rarely does, by the way. And in addition to LiDAR, so these technologies are used in combination. So LiDAR would be very good for forming a 3D image of the surrounding area to know how does my environment look like. When it comes to radar, radar can actually now measure the speed of objects or vehicles near the autonomous vehicle. So LiDAR will enable the vehicle to see the street and the buildings and other vehicles, but it will not be able to measure the speed. Now, one thing with the radar detection, for example, if you look at Teslas, they often mostly use radar. And even vehicles today that have more advanced features of cruise control, they usually have a radar sensor and transmitter on the front. Like if you look at most of these high-end vehicles that come to the market today, like the Range Rovers and the Toyota Land Cruiser VX, behind that logo of Toyota, when you look at a Land Cruiser VX, the high-end, the high-spec ones, that logo of Toyota in front of a Land Cruiser, behind there, there's a radar equipment that can measure the speed of the vehicle in front and make some decisions. For example, if you're cruising on a highway, if you're cruising on a highway and the vehicle in front of you reduces speed and you are using cruise control, your vehicle will adjust the speed to that vehicle and continue tracking it until it's safe to overtake. So that is radar. Radar is essentially for measuring the speed around of surrounding vehicles. Sonar, on the other hand, is similar to LiDAR and radar, but now uses sound. And because it uses of course, it's sound that is of a high frequency that is inaudible to our human ears, but it's still sound. It is short range. So cars that have things like automatic parking assist, like the new BMWs that have parking assist, use sonar to navigate. People usually wonder, how does this car end up parking itself like this, parallel parking itself? It's because by use of sonar, the vehicle is able to accurately detect spaces around it or vehicles next to it. And by use of sonar, some lane assist systems use sonar. For example, when you're driving some of these high-end cars, they have what is known as lane assist. Other than just the lane keeping mechanism, like the one that we've seen in the example that was mentioned for the Subaru. Some vehicles, when you maybe try and change lanes and there's a vehicle in the blind spot, there's usually a beep, and the beep is more intense if the vehicle is closer. In some vehicles, if there's even a light at the side mirror, which blinks to warn you that there's a vehicle on that lane you want to change. That is an example of sonar. So these are technologies that are already being used in various ways or the other to various levels of automation. So a BMW that is in Nairobi that has park assist or automatic parking, then is at a certain level of automation from the level you saw from 0 to 5, and so on and so forth. So sonar is also being used in autonomous vehicles. Then of course there are cameras, and these cameras usually overlap. This technology is already available, for example, in some cars where by use of cameras all around the vehicle, you're able to have like a bird's eye view of the surrounding of the vehicle. And some cars usually show you that even as you try reverse or park, you have a bird's eye view of what the surrounding of the vehicle looks like. Maybe there could be a child or a small object that you might hit when reversing to park or something, especially for big vehicles. And of course, these are specialized cameras. And then the other thing that we mentioned, of course, is positioning, where we use satellite tracking such as GPS, Glasnost, Galileo, to do tracking and navigate around. And this, of course, is used in conjunction with the maps. Yeah, the GPS data is used in conjunction with maps and the data that has been received by all these other sensors. The question then comes in is why are we talking about all this? It's because, let me give you an example. The Federal Communication Commission in the US, FCC, which is the communication regulator, recently, due to the increase in number of autonomous vehicles, they
Umepotea. Can't hear.
Can you hear me?
Yes, now.
Okay. Let me reshare the screen again. So the regulator, as I mentioned, why are we talking about radar, LiDAR, and all that? As I gave an example, the Federal Communication Commission in the US recently increased the spectrum allocated to vehicular radar from the existing 76 to 77 gigahertz to 76 to 81 gigahertz. So this is an example of a regulator taking action to ensure that the deployment of autonomous transportation systems is smooth and successful by availing the spectrum to do radar detection. The regulator also maybe is working in the case of the US towards looking at methods in which they can prevent interference as more vehicles come on the road that are using radar for navigation. Then the issue of interference comes in. So there are various methods that are used to counter interference, depending on the country or the manufacturer. So the regulator also comes in terms of saying that this is what we think should be the minimum standard of maybe the equipment that an autonomous vehicle should have when coming into Kenya. These are the requirements that this vehicle must meet for it to drive on Kenyan roads or for it to utilize the spectrum that we have allocated for these services. Because remember, not all cars are equal. The same way we had the issue of counterfeit phones, where yes, it's a phone, you can make phone calls, you can do all what you need to do with, but the phone is poorly designed and of low quality. Maybe its transmit power is excessive, or maybe the radio electromagnetic requirements for the phone have not been met and all that. So slowly, we are seeing non-traditional players in the regulatory space for transportation taking their rightful position in as far as regulation is concerned. So I'd like us to look at an example of self-driving vehicles. This is a self-driving truck used by UPS. This has been in use for over 2 years in the US. So this is not something that we are talking about that is very futuristic or will be available maybe in the next 50 years. As we've said, fully autonomous vehicle level 4 has about 10 years to go. But that does not mean that, and by 10 years we mean like mass adoption. That does not mean that the technology hasn't reached a level where it can be applied. A good example is UPS, which has been using for the last 1.5 years actually, driverless lorries to transport things around across the US. Uber, I think last year, had a lorry that drove to supply beer without a driver in it from the beer depot all the way to the customer. There was no driver involved. So let's look at this video and see.
While you're still waiting for that package that was supposed to be delivered on Monday, UPS has been secretly hauling cargo using self-driving trucks. That's right, the company has put its minority stake in automated trucking startup Too Simple to work. For over 3 months, self-driving trucks have been hauling cargo back and forth between Phoenix and Tucson, Arizona. The tractor trailers are outfitted with 9 cameras as well as LiDAR sensors, those spinning contraptions often attached to the roofs of self-driving vehicles to help them see. The fleet is designed as level 4 autonomous trucking, which means all operations are automated. A driver and engineer are only on board as a fallback. The effort aims to reduce the cost of shipping by 30%, likely by eventually removing the human occupants once the technology has been perfected. This isn't UPS's first foray into autonomous navigation. Earlier in the year, the company announced a program that will deliver medicine over short distances via drones. Meanwhile, FedEx has revealed an adorable robot for same-day deliveries, and Domino's is planning to use Neuro's self-driving R2 vehicles later in the year. In other words, you're going to start seeing a lot more robots sometime in the near future. We just hope you keep your prejudices to yourself. Thanks for watching, and remember to like and subscribe to Engadget.
So that's a video that shows that these technologies are not just in academic journals or documents. That these are actually technologies that are being used right now by businesses to add value to their customers. Maybe, for example, in that drone that we saw, through quick delivery of medicine. We'll see another example when it comes to talking about drones. Or the fact that UPS estimates they can cut their transportation costs by 30% by using autonomous vehicles. And the reason is simple. It's because in the US, unlike Kenya, where the laws are not strict, in the US, a lorry driver can only work certain hours, and he must take a break during that period of time and be absolutely away from the road for safety reasons. So if he drives for 8 hours, he must take another maybe 8 hours or 12 hours break before he continues with the journey. In Kenya, of course, and in many African or developing countries, that is not the case, because we see situations where a driver leaves Mombasa and drives all the way to Kampala or to Juba, sometimes just taking 4-hour breaks, which of course endangers the driver and other road users. And we've seen very many dangerous accidents where the driver just falls asleep. So with laws like that in the US, it means that a lorry owned by UPS is half as productive as a lorry owned by a Kenyan transportation company. Because the lorry by the Kenyan transportation company will be on the road throughout without the need for the driver taking a break. So that has been a pain in most transportation organizations in the US. So having a driverless lorry, of course, means that that lorry can travel 24/7 if it's mechanically fit, of course. And that, of course, will virtually double the transportation capability of these organizations. If you have 10 lorries, that can only do 8 hours in a 24-hour period, and all of a sudden these lorries can do 24 hours, then you've effectively doubled your transportation capability from 10 lorries to 30 lorries. And to retrofit, basically to take an existing vehicle like the one we saw and make it self-driving would cost, as of last year, cost about $30,000 to make it self-driving. $30,000. That is less than the salary of a trucker in a year. So you see where that is going. That organizations that find this beneficial are now working towards ensuring that the vehicles they buy can be converted. You can actually convert an existing vehicle. Like the one we saw there, that vehicle wasn't designed and manufactured as an autonomous vehicle. It was retrofitted by the tools and the equipment that we saw, and of course there are control mechanisms to control the steering and the acceleration and braking and all that, other than just detecting the environment. But it's about $30,000, which for a company like UPS that is in the transportation business, that is a very good investment for them, because with just $30,000, that one lorry can now do 3 times the work it would have done had it been human driven. So these technologies are actually driving, these organizations are actually driving the desire and the research and development of these systems. We had Uber. Uber bought a transportation company, one of these lorry transportation companies, autonomous companies, that was developing, I think it was called Auto. Auto Trucks was developing a technology for autonomous trucks, and they were bought by Uber. And Uber is working towards developing this technology, because it is going to be of immense benefit to the US in as far as the business's productivity is concerned. In our case, the benefit would not necessarily be in terms of business productivity, because already businesses are floating the law in as far as observing driver alertness and health is concerned, but it can come in a big way in terms of safety. So our focus would be maybe to ensure that whatever systems we bring here are safe enough to or enhance the level of safety on the roads. As more and more autonomous vehicles or lorries come on the road, then we should see a corresponding improvement in safety. So when you talk of autonomous vehicle players in the market, what are we really looking at? The most famous one, of course, is Tesla. Most people know of Tesla because of their excellent marketing. But there are other players in as far as autonomous vehicles are concerned. Waymo is one of them. It was previously known as Google Autonomous Vehicles, but now it's known as Waymo, and it's owned by Alphabet, which is the parent of Google. And the reason why Waymo is receiving a lot of attention in the AV space is because of its ability. Again, this is Google. What do you expect? The ability to drive the longest without disengagement. That is to say, they have the lowest disengagement rates. And by disengagement, of course, we mean instances where the driver had to take over because maybe the vehicle was unable to decide. And theirs is about 5,000 miles. So on average, Waymo vehicles have been able to achieve over 5,000 miles of no disengagement. I mentioned Uber. Uber is very strong in the ride-hailing space, but they are putting in a lot of money in autonomous vehicles. Why are they doing this? It's because if you look at the cost breakdown of an Uber ride, the biggest percentage of that money goes to the driver. So Uber makes very little. In as much as that is an Uber managed taxi, a huge percentage of that money goes to the driver and not Uber themselves. So by eliminating the driver, Uber would actually to significantly increase their share of the money that riders pay. If I pay 300 today in an Uber, more than half of that, actually more than 3/4 of that would go to the driver. And the remaining would go to the ride-hailing company. So to them, it is in their interest to increase their share of that money by eliminating the driver altogether. And again, as I've mentioned, in the US, in terms of the regulation around trucks, investing in truck businesses, automated vehicles, especially in trucks, is becoming very attractive, and Uber has also invested there. The challenge, however, is that auto trucks was started by engineers. Majority of the engineers who started auto trucks were ex-Google engineers. And some of these engineers happen to have stolen some intellectual property of Google for self-driving. So Google, basically Alphabet, sued Uber, and there was a protracted case on that. You can read about it online. And then also the other thing that have happened, I think we all heard that story where one of the Uber self-driving Volvos killed a pedestrian in the US. Though there are so many theories surrounding what really happened and why that vehicle made that decision, or what the person who was killed, unfortunately killed, did to contribute to their death. So all that is online. So there are controversies surrounding Uber. Now, one thing you need to note is that these players are focusing on niche areas. They don't just do generally autonomous vehicles. For example, Waymo is focusing a lot on personal commute. And the initial Google autonomous vehicles were very tiny. Could fit maybe one person or two at most. So they are focusing a lot on personal commute, like a commute pod. Not really a car, but a commute pod. Uber is focusing on tracking and robotic taxis. Getting rid of the driver would be very good for them, so they're putting money there. Then the third one is an organization called Zoox. And these guys are mostly focusing on designing robotic taxis that are based on Toyota vehicles, Toyota SUVs. And the advantage that Zoox has is that their design is in such a way that they are focusing on robotic taxis in environments where the streets are narrow or crowded, or and this forms majority of European streets. If you look at most European streets, which are very ancient, most of these towns are very ancient from the Roman times. The streets, some of them are still very, very narrow. So that also poses a challenge for vehicles. So Zoox is focusing on that. Some older cities in the US also have very narrow streets. Like, for example, San Francisco has very narrow streets. Newer cities do not have that problem. So Zoox is working towards that. The other player which is common is General Motors. There's a company called Cruise Automation, which they acquired, and that was their way of getting into the automated, autonomous vehicle space. One thing you need to realize is that this list does not have the traditional players, the Fords, maybe General Motors is there, the Toyotas, the Volkswagens. Why? Why is that? It's because for quite some time, these businesses did not really think that that was a threat to their business model. But in the last 3 to 4 years, they've realized that this can actually mean our demise. And Tesla's performance has shown that. What General Motors is focusing on is mostly carpooling or ride sharing. So whereas Uber wants to make you hail or book a driverless taxi, what GM is saying is that we want to design our cars so that these cars can be very effective for ride sharing, communal cars basically. So in a scenario where maybe in my estate, in my court, maybe we might have 3 cars. for all the houses. And these cars do not belong to a particular homestead. Right now, okay, like maybe where I live, every homestead has at least 2 cars. And the challenge with that is that most of these cars are maybe often parked. And it's not efficient from an economic point of view, from a financial point of view, from an environmental point of view, and from an infrastructure strain point of view. That's not effective. So GM is trying to solve that. Tesla, on the other hand, is famously known for electric cars. That is what they do. Autonomous vehicles is an addition to their base business model, which is providing electric cars. Tesla usually says that whatever they sell is not a car; it's a computer. Yeah, they don't term those as cars. It's a computer. It has hardware, which happens to be in the form of a vehicle, and it has software, which of course now does the navigation and very many other things. And one thing unique with Tesla is the car software can update via the air, like via 3G or 4G or Wi-Fi. So if there's a new software release by Tesla, the same way your Windows machine receives an update from Windows, is the same way your car will receive a software update. And this is actually the way to go for most vehicles, because then if there's a bug, maybe a safety bug that has been discovered, or if there are enhancements in how the algorithm runs and makes decisions, then a software patch can quickly be dispatched to all vehicles at once. So within very few hours, an update can be received. Or for example, if there's a security loophole that is now being taken advantage by hackers, because you can imagine if the street is full of autonomous vehicles and somebody is able to hack, maybe like in Kenya, they always say that the car in front is always a Toyota. If we're in a situation where the street is full of Toyota cars sharing similar software and navigation system, and then there's a flaw, and the hacker is able to take control of all Toyota cars maybe, and maybe do something foolish, like decide that I'm going to switch off all the vehicles wherever they are, and they're not going to power on. So with Tesla, they're able to send an over-the-air update via 4G, via basically the normal way we communicate to the internet to that vehicle and update the software. Our biggest problem now as internet citizens is because, especially outside China, we rely so much on the Western version of what is really happening. But if you go into China, there's a company called Baidu, which is an internet company, which is also known as the Google of China, because the operating model, everything. The other time, even their logo looked very similar to Google, including the colors. But Baidu is working with the local Chinese companies, including the state-owned FAW group. I'm sure you've seen all these China construction company lorries, like all of them are FAWs. So that's one company. There's Geely. Geely is a local Chinese company. Currently, you can buy a Geely at these guys who sell Mitsubishi on Mombasa Road. They sell Geely. They've also partnered with Ford. And one thing that Baidu has achieved is that their vehicles, which are mostly geared toward robotic taxis, have done over 1 million miles in China as of last year. So that is significant advance in as far as the design, operation, and testing of these vehicles are concerned. There are many other smaller players who are doing niche things. There are players who are in the autonomous vehicle space, but not necessarily manufacturing cars. But some of them are working towards enhancing these technologies. For example, I mentioned a situation where the increase in use of radar in vehicles will end up causing interference. There are companies that are doing research in terms of countering that, maybe doing beamforming. But then when you do beamforming in radar, which is supposed to detect obstacles, beamforming limits the view angle for that radar system. And what happens then is that, yes, you've done beamforming and you've avoided interference, but then the challenge is you can't see as much as you'd have seen had you not done beamforming. So therein comes the challenge. So there's a lot of work going on there. And how does the government or regulator comes in? How do they come in? And they come in form of ensuring that minimum standards or specifications are set in as far as autonomous vehicles are concerned, and rules set in terms of, for example, the security of these softwares, the update. Like a government might decide, because we are very keen on ensuring safety in the country and the safety of the vehicles in the long run, let us ban the import. Sorry, there's somebody who's not muted. Kindly, let's check. Kindly check. So the government might decide, let's set rules that any vehicle imported in Kenya must meet these specifications. For example, a vehicle that cannot update via the air, its software, then cannot be imported in Kenya or has these limitations. Yeah. Or if vehicles are being imported and they are now using radar and LiDAR, what are the emission limits, radiation limits that we should set in terms of the power, so that maybe don't end up causing undue interference or interfering with the medical equipment and all that. Yeah. So that is what needs to be looked at. So this is a video which I'd like you to watch very carefully and see what a Tesla car driving in a street in the US sees. And there's a time I mentioned that there was an organization in Kenya that does labeling of street signs and maps. So what this organization does, that the people who work there are given very many random images of various streets, intersections, highways in many countries, and they label this data. If it's a stop sign, they select it and say stop sign. If it's a lane in the middle, they say this is a lane separator. If it's a traffic light, they mark it. If it's a dustbin, they mark it. If it's a tree, they mark it. If it's an animal, they say that is a cow. If it's a person, that is a pedestrian. So let's see all that put together into a Tesla. I'm not sure, maybe some of this labeling we are going to see here was done by a kid in Kenya working for that company, because that company employs youngsters, of course, above 18, but students who are in university, colleges, or freelancers. So this is what a Tesla sees based on the equipment that it has and the data that it has about the various road signs and conditions. And you'll see somewhere it's even able to see water that is on the road and how much water it is, and make the necessary decision.
Tesla Autopilot. It's the most well-known driver assistance system in the world, and its features have impressed millions. But it's even more impressive than meets the eye. When people think about Autopilot, they tend to look at what it can do. It can keep you within a lane, even in tight curves. It can adjust its speed to match the car ahead of you. It can change lanes on its own. It can take highway exits on its own. You probably already know all of this if you've ever used Autopilot, if you've witnessed it, or even if you just looked into it online. Now, this stuff alone is incredible, and it's enough to amaze almost anyone who gets to see it in action, but trust me when I say that this is just the tip of the iceberg. The key to seeing how impressive autopilot actually is lies in the smallest details. In February of 2020, Tesla released this 30-second clip showing an example of what the forward-facing autopilot camera sees, along with all the annotations made by the computer, which demonstrates what the system understands about the world around it. Okay, so at first glance, it looks pretty complicated, but also pretty cool, right? Let's take a closer look at the details. Let's start with these arrows on the road. Now, we've all seen these before, indicating which way you can turn, but look at how they're labeled. LA, FA, and RA. That's left arrow, front arrow, or forward arrow, and right arrow. These are correctly labeled by the system. If we keep advancing, we can already see LA, FA, and RA in the distance. Now, if we move closer, it reveals that those are correct annotations of each arrow. If you're not impressed yet, just remember that this is a computer recognizing arrows on a video that it has never seen before. Alright, let's talk about stop signs. Now, there's a stop sign coming up, as you can see here in the intersection, but if we rewind to go see where Autopilot first saw that stop sign, we can see that it actually found it really far back, all the way out here. If I can find this frame. And if we zoom in, we could see that stop sign labeled and outlined in red. Now, if we keep going, as we approach the intersection, we can see that not only is the stop sign labeled, but the line where the car should stop is also labeled with a red line, as well as the letter S for stop. Over here we have another stop sign coming up, and as you can see, it's labeled with the red outline as well as the stop line. And even though that truck was there, it still managed to properly label the stop line. Pretty impressive. Alright, next up is probably my absolute favorite part of this video. It's super impressive. So if we look here on the left side, the third row from the bottom, there's a value called a wet road with a number value associated to it. Now I want you to pay close attention to the number and the value associated to wet road as we approach a puddle in the distance right in front of that stop sign. So as we go forward, the puddle begins to come into view, and there we go, wet road has increased and is highlighted in green or yellow. That is just one of the most impressive things that I have seen Autopilot do. And if you're not impressed, then you should be, because this is a computer recognizing water on a road from a video feed that it has never seen before. Now, another very interesting thing we can see in this clip is the little red X that appears right where the road splits to go left or right. Now, I suspect that this red X is the system labeling the lane line that goes to the right as a lane line that Autopilot should not follow. This is brilliant because the car is in the left lane and the system recognizes that and labels the right lane line with an X so that it does not follow it. Now, if this little detail doesn't seem very impressive to you, try to put yourself in the shoes of a computer. You as a human have deductive reasoning. You obviously know that you should not be following that line, but the computer has to take all of the information it has in the surroundings to make a decision about whether or not it should follow that lane line. This is a computer that we're talking about, and the fact that it can use that information to make that decision is extremely impressive and gives me hope for Autopilot actually completing full self-driving in the future. In terms of traffic lights, we can see here that there are two green lights at this intersection. They are both labeled by green rectangles, so we know here that the cameras and the computer recognize both the color and the location of both of these traffic lights. Next, let's take a look at how cars are labeled. Now here you can see that there's a yellow 3D box around all cars that Autopilot can see. And as we make this turn here, there's something interesting about the cars parked on the right. Even though the cars are not fully visible, the system still predicts those boxes and where they are. Another interesting thing we can see here as the car drives along is that on the right side, where the cars are parked, we can actually see that the computer indicates a line, a lane line. Even though there's no actual line painted, the car recognizes that those parked cars are a border in a sense where the car cannot go, and therefore puts a lane line. I'm sure that there are some other things in this video that I did not pick up on, but those are a few things that I found extremely impressive. And honestly, it's a look into the future of autopilot and what it really is capable of. And I think this is proof right here that full self-driving is definitely possible and that it will occur sometime in the future. But the bottom line of this video was just to show how impressive autopilot really is. It's a lot more than you see on the surface to actually see what the computer understands and what it does. So I just wanted to share this since I was so impressed by it. That's it for this video. If you have
So we've seen an actual use case of Tesla, which, as we mentioned, is not really a fully autonomous vehicle. And even if it's autonomous, even if it has the autonomous capabilities, the driver, as you've seen in this video, has to legally remain where they are. They might not be holding the steering, but they need to sit there. And we've seen how the various sensors and data is being used and interpreted by these systems. And of course, again, the question comes in is, if these vehicles are being designed to interpret this data this way, and using standard stop signs and all that, what do we need to do to prepare to be compliant when this adoption happens? I'll give you an example. When the Southern Bypass was completed, there was a sign that was put on the Southern Bypass on several spots indicating the speed limit in terms of the minimum and the maximum. That was not a standard legal road sign. It was just a sign, but it's not standard. There's nowhere else in the world that that sign existed, where it indicated minimum limit for minimum speed 40, maximum speed 100. There's nowhere. So by ensuring that we adhere to standards and standardizing our infrastructure and operations in as far as maintenance of this infrastructure is concerned, we need to ensure that we prepare ourselves for the adoption of these technologies. As we've seen, it's very complex. It's able to detect very many things, including which side of the road it shouldn't drive on, and many other things.
any questions?
Now, that is what we can say about autonomous vehicles. We'll cover the regulatory aspect again once we cover another form of autonomous vehicles, which is known as unmanned aerial vehicles. But before I proceed, maybe are there any questions so far? So we can continue. Now, autonomous aerial vehicles, most people commonly refer to them as drones. And a majority of people know a drone by what they see often, which is usually one type of drone, the quadcopter. The one with four, like the one you saw in the UPS advert. That is one form of drone. That is a quadcopter drone. But there are many other different types of drones, as we'll see later. And the initial application and the most famous use of application, of course, is in military. The US is very well known for using military drones everywhere in the world, including Somalia. So these drones are able to fly from military bases and do reconnaissance missions or carry out attacks, or even they're used even sometimes for military training. So the military use of drones is responsible for the advances in as far as science and technology is concerned of drone technology. That now it's possible for a drone pilot seated in US soil to pilot a drone in Somalia, and it's as good as if the pilot is actually in the drone itself, because they use sophisticated mechanism. Like some of them have started using VR, virtual reality, where the pilot is wearing virtual reality goggles and has a view similar to the view he would have if he was seated in that drone. And when you talk of drones, we don't talk of small drones the way we know them. Some drones are very huge. Just allow me to search one photo of a drone. Just hold on. Can I share with you? So when you talk of drones, we can talk of something as small as handheld as this. Yeah, this is still a drone. Or we could talk of something as big as this, as you can see here, compared to the people here and the vehicles. Or something even bigger. I'm looking for the best picture to show you this. You see this? These are the drones that, for example, if you hear the US has bombed a certain country using military drones, it's not something small like that can fit in the boot of a car. It is as huge, as big as a military aircraft. This is a drone. So basically, we've simply removed the pilot from a military aircraft and called it a drone or an unmanned vehicle. So they're not small things. They're very huge. They're as big as aircraft, as you can see there. Or they can be as small as something you can hold in your hand, like this guy. Yeah. And there are various types and sizes, as this photo shows here. NATO, as they're saying here, NATO is even developing a classification system for drones for military purposes. The other use, of course, is civilian use, which is now taking root. And the reason why civilian use is taking root is because the technology has matured to such a level where, and thanks to military, to such a level where it is becoming now more efficient and cost effective to use drones for things like parcel delivery. UPS is using parcel delivery drones in test phases. Amazon is also doing parcel delivery using drones. And we've seen there that it's actually something that is being done in the US, though not at a very large scale. There are many things that need to fall into place for that to go large scale. And we'll see that later. They're also being used in some operations like power line and pipeline inspection and all that. I think a few months ago, we saw a video of Kenya Power engineers being lowered down to the cables to repair them somewhere in Kiambu when there's a major fault affecting Nairobi. Yes, the use of a helicopter worked, but you saw the challenges that the engineer had due to the downdraft of the helicopter rotor. So it's not as optimal. It endangered him It was expensive because Kenya Power needs to maintain that helicopter. They need to pay parking fees at the airport. They need to pay a pilot a lot of money. And that pilot doesn't necessarily fly every day, by the way. So there's a lot that can be saved by use of drones for such work. Inspection also of power lines and major oil pipelines and all that. Drones are also being used in agriculture for irrigation, for spraying of pesticides. I think it was Pakistan, I can't remember, but in this recent locust invasion, which also affected them, they were using drones to scare away the locust swarms. So the users are becoming many. And of course, there is the use of drones in search and rescue missions. In difficult to reach places, drones can be able to do that. Not necessarily saving the people, but a drone can have a camera attached to it, and it can navigate to places where maybe people are being searched for, if it's a search and rescue mission, and relay what its camera sees back to the rescuing team, and decisions then can be made. And then, of course, in communications, around 2012, 2011, Facebook had bought a drone company, and their plan was to use these drones, make them solar powered, for example, and use them to deliver communication services to people. So let's say over Nairobi, you'd have like several drones just hovering up there above the air, not very far, a good distance. And instead of using, for example, cell towers, you'd use a drone to broadcast the signal over a larger area than a cell tower would. And of course, it'd be cheaper to do that. But Facebook seems to have abandoned those plans, and they are not putting a lot of money into that. We've all heard of Google Loon. Google Loon is actually undergoing tests in Kenya. You've all heard about its intended use in Kenya, especially in providing 4G services. But that wouldn't be classified as a drone per se. It could, depending on what your definition is, but for the purposes of this course, we wouldn't classify that as a drone. And many other uses. Now, the growth and popularity of unmanned aerial vehicles again stems from the fact that the military put a lot of money in research and development of this, and as the technology matured, it found uses in civilian use also. It found application in civilian use. And this is not the first technology to do that. There are many other technologies. For example, I gave you the example of GPS. GPS is a US military system that is used specifically. The reason why they put it up there in the sky was for military purposes, but it's now available to civilians for free, for that matter. So this graph basically shows that the use of drones is increasing. At the moment, we really can't say
We can't hear you. We can't hear you.
Same here. Tom, we can't hear you.
It's muting me randomly. But can you hear me now?
Yes.
Sorry about that. So let me know when you see the screen. I've reshared it again. So one area in which drones are being used is, as I've said, in the medical field, in the delivery of medical supplies like blood, urgent medicines. Maybe in future you might see organ transfer and all that happening by use of drones. So this is a video showing how one company called Zipline, which operates in Rwanda, is using drones in real life scenarios to deliver blood to hospitals within Rwanda. Rwanda is very small, so from Kigali, the drone can fly to whichever area of Rwanda and deliver the blood within a very short period of time, sometimes within less than 15 minutes. So let's watch this video.
Meet the company that's beating Amazon to drone deliveries. Zipline has already logged over 186,000 miles and completed more than 4,000 deliveries since 2016. The company has focused on delivering blood and life-saving medical products to hard-to-reach areas in Rwanda, but will soon expand to other developing nations and even the US.
The service that Zipline provides allows any doctor or nurse anywhere in the country to basically send a text message and get the product that they need 15 to 30 minutes later.
Like traditional logistics companies, Zipline is paid per delivery. Its drone system is 4 times faster than the average quadcopter and can serve an area 200 times as large. 1/3 of the deliveries in Rwanda were for life-critical situations.
If a patient shows up at one of the hospitals and happens to need a transfusion of that blood type, Zipline actually can deliver that specific product from our distribution center to the hospital so quickly that the patient actually doesn't know the product wasn't stocked at the hospital to begin with.
Here's how it works.
When that text message is received at the distribution center, we will immediately take that product out of our central store, load it into a box, and then that box gets placed into one of our zips, which is one of these autonomous aircraft.
Once loaded, the drone is catapulted into the air on a launcher. Using military-grade GPS, the drones navigate to the healthcare centers that Zipline serves and drop their package from the air on a paper parachute before returning to the distribution centers.
We're actually using an active recovery system that takes inspiration from an aircraft carrier. We're actually tracking the plane with about centimeter level accuracy, and we can pluck the plane out of the air and then basically swing it down so that our flight operators can immediately grab it, load a new package, and launch it again.
Zipline will start making deliveries in the U.S. this year as part of an FAA pilot program. The company says that it has already partnered with a number of healthcare systems, states, cities, and research institutions in the U.S.
Learning from Rwanda's example, the U.S. is now moving really quickly to show how this kind of technology can save lives and be commercialized here in this country. And what's exciting is that Zipline's second-generation aircraft and second-generation distribution center are coming online in the next month, and they're going to make it possible for us to go from serving a small country like Rwanda at limited scale to a much larger country like the U.S. At a scale of hundreds of millions of people.
So this is actually a very good example of how Africa is actually providing a form of leadership in as far as utilization of these technologies is concerned. zipline ownership and shareholding structure being immaterial here, considering this is actually being tested and has been proven to work very effectively in Africa, and now they are moving this technology to the US, means that this technology is being developed from a level where our problems are already addressed, because there are many scenarios that are in Rwanda that are very similar to other African countries, mountains, maybe even vandalism. There are instances where maybe a drone is shot from the sky by people for whatever reason that might prompt them to do that. But as you've seen there, these drones are actually working very successfully in Rwanda to deliver blood, to deliver basically essential medical supplies, blood, medicine, etc. Any question up to there? So if there are no questions, then I'd like us to move to our last slide, where we will discuss how regulation ties into what we just discussed. Maybe just to emphasize that when you talk of regulation, it does not mean the regulation in form of control, but progressive regulation. Regulation that will put in place measures that will, for example, lower barriers to entry for players in, for example, that example we saw of drone delivery, or level the playing ground. If there are many players and some are disadvantaged, how does regulation level the playing ground? How will the allocation of spectrum be done for the control of these drones? Remember, these drones are being controlled using radio. Will it be on 5G? What is the requirement for these operators, for example, mobile operators, when it comes to SLA that is being guaranteed on a drone delivering medical supplies vis-a-vis a drone delivering a book that I ordered online? Because those two shouldn't really enjoy the same quality of service. I'm just saying, I'm not saying that should be the case, but ideally the one that is delivering critical supplies, there has to be measures of guaranteeing the quality of service as far as communicating with that drone is concerned. When it comes to drones flying around in Kenyan airspace, there are other regulators also who will come in as far as aviation is concerned, the Civil Aviation Authority, for example. But the biggest concern actually is the algorithmic design for decision-making in these systems. That there needs to be a minimum standard to which we hold ourselves to in as far as automated transportation systems are concerned. What philosophy should we adopt as a country in as far as the algorithms are concerned? What measures should we put in place to ensure that our offline biases, for example, are not carried into the digital space when we innovate and use these technologies? Yeah. And I give you an example of offline bias, especially in Kenya, would be tribalism. If a car is driving down the street and it's fully automated at level 4, and it needs to make a decision, that decision might either kill you if it doesn't make that decision, and if it makes that decision, then somebody else might be harmed. What criteria is used to determine which person should be harmed? Like if your vehicle is in the middle of a lane and there's another vehicle on this side, somebody from, I'm using this as a Kenyan example, I'm not saying that is what happens or that is what will happen. It's somebody from a political side that you do not agree with, and on the other side is somebody who is driving a vehicle from a political side that you agree with. Should that vehicle make that, because that vehicle will have that, might have that information, yeah? There's a way in which that vehicle might have that information that, oh, or an example is maybe it's driving down the lane and on one side is a GK car and on the other side is a private car. It needs to make a decision on which side to swerve. Should you swerve towards the GK car or the private car? What decision needs to be made there? So our offline biases, there's a huge danger that our offline biases will be transferred to the digital space when we do these things. Another example I gave when it comes to regulation is the technology and the suppliers of this technology. We saw how the US is getting edgy with the use of Chinese 5G chips in their networks, because they are envisaging a scenario where the entire transportation system, for example, in the US is running on 5G, and this 5G network is running on chips supplied by Huawei, and Huawei has ties to the Chinese government, and maybe there's a disagreement. What will happen there? Yeah. So if you're designing systems, even in Kenya, those geopolitical considerations need to be looked at, and that also will come into regulation. For example, if we are using this type of autonomous vehicles, then this is the technology we use, or this is the chip manufacturer we will use, etc, etc. So there's a lot. I cannot really speak of everything that touches on regulation on the digital space and AI, but there's a lot that needs to be looked at from a regulatory point of view. Then with the UAVs flying around delivering pizza and medicines and all that, we'll need new traffic laws for the lower space, maybe. Whereas we are at the higher altitudes, we have aircraft controllers managing the flow of aircraft in Kenyan airspace. In the next 10 years, maybe Mama Mboga will have a drone to be delivering her produce to her customers. What will be the laws around that? What radio frequency will we allocate for maybe an unlicensed zone where, because delivering Mboga isn't really a critical issue, let them use the unlicensed band. What band will we allocate? But we say maybe if it's a drone delivering medical supplies, it must use this type of band that is more controlled and suffers less interference and all that. So these are things that we need to look at in as far as allocating radio frequencies for autonomous vehicles. And we saw an example of the Federal Communication Commission increasing the allocation done for radar significantly because they see that the need is increasing. So we need to start preparing on that front and say that considering this is where we're going, this is our new allocation scheme, RF allocation scheme. Of course, there are guidelines from the ITU in terms of allocation and assignment, and those will have to be followed, but you can modify. These are just guidelines. We can modify them to suit our environment. Then I've also mentioned in terms of these systems, for example, in connected cars, how will we hold the service providers, for example, the connectivity service providers, to ensure that they maintain the service level agreements promised and the quality of service for autonomous vehicles and such. So there is need for that to be looked at to ensure that in instances where quality of service has to be guaranteed, what criteria or what parameters are we going to use to ensure that that is achieved? And then, of course, there's the element of these systems now becoming more of computers than maybe transportation tools or vehicles. In fact, Tesla calls their car a computer. Tesla is in the computer hardware business, according to them. It just happens that their hardware can also drive on roads. That's what Elon Musk wants to believe. And with that approach, they'll focus a lot of their energies on innovation on a new space. Because if they're in the automotive industry, they'd focus their energies maybe in getting people to commute. But maybe what they want to do is revolutionize the market. As you saw in that video, they put a lot of money into R&D in self-driving cars. So we could have regulations maybe that, you see, the same way we say a car older than 8 years cannot be imported into Kenya. Why is that? Is it because 8-year-old cars are slow or ugly? No, it's because of emission levels. Because an 8-year-old car will pollute the environment more than, a car that is older. 8 was just a limit. Some countries can set it to 5. There's a plan actually to lower it to 5 in Kenya. I think in 2018, if I remember. But it's a limit that can be adjusted. So that is a law that is currently there. Maybe in future, whereas now we are saying we need a car that is less than 8 years old to be imported to Kenya, maybe in future we might say, if we are importing autonomous vehicles into Kenya, they must at least meet this software version, or they must be able to transmit at this frequency band, or their processing CPU must be a minimum of this number of megahertz, etc., etc. So that you do not have a situation where the infrastructure and the communication system thereof are way advanced than the car that is using those systems, and it might miss out some safety features or some capabilities might be absent because of that age. So those are the things that we need to look at. Whereas initially maybe it was a Kenya Bureau of Standards that says, or maybe NEMA, these are the limits for a car coming to Kenya based on emissions. New players are now coming in also in that space, like the regulator, the ICT regulator. Now, in addition to just saying a car must be this years old, we can also say maybe this car's bandwidth to connect to the next base station should not be below maybe 1 megabit per second, just as a rough figure. Or these vehicles that we're importing into Kenya must have software that is updatable via the air. You do not need to take the car to the garage to plug it into a computer to update the software. Maybe we might say that as a bare minimum, any car coming to Kenya, of course, it has to be phased. It's not just a blanket application. It has to be phased and staged depending on our capabilities and needs. We can set maybe minimum software specifications, minimum communication specifications. Maybe if a vehicle is autonomous, of course, it has radar. What are the maximum transmit power levels that a vehicle should have to avoid interference? For example, if in future beamforming will have advanced in a way that we can use it to avoid interference in radar, what is the beam width that we'll be looking at? The half power beam width for a radar transmitter in front of a car, because if you plot the transmission, the radio transmission from any transmitter, it will always form a beam. So how wide or how thin should the beam be? All those specifications are now coming into play, and these cannot be set by the traditional transportation regulators. Yeah. Then the other thing when it comes to regulation is even maybe changing how people are taught driving. Yeah. There could be new traffic laws. The same way right now we are saying we need a BRT lane on Thika Superhighway for high capacity traffic like buses. We might say, for us to encourage the use of electric cars or autonomous vehicles, we might create a lane for them. Kenya might be tricky, but in the US, there are lanes already for high occupancy vehicles, for example. we might want to modernize our authorities, the police, the transport safety authority, for example, to be capable of working in this new environment and infrastructure. So there's a lot that can be discussed around that, but this is simply to jog your mind and see that it's not business as usual. Even as we talk about moving to this new era where we are talking about autonomous vehicles, drone deliveries and all that, what are we doing right now to prepare ourselves for that? And it's not something that can be done in a week or in a month. It is a concerted effort. A multi-sectoral approach is needed. And if it's a multi-sectoral approach, it will involve regulators such as the Communication Authority, the NTSA, the Civil Aviation Authority, standards bodies such as CABS, private sector players such as car manufacturers, car importers, garages, and so on and so forth. So with that, we will now be able to actually utilize these technologies to achieve some of the things we've mentioned in the SDGs. Safer transportation would, of course, lead to better lives for people, as we've seen, more efficient economic systems and all that. And maybe something else that I haven't touched on, we've only been talking about regulation in terms of AVs and UAVs. But there is more in as far as regulation is concerned in the automation space. Remember, we talked about things to do with artificial intelligence scripts, which are basically online robots and algorithms. Maybe we might need a way to regulate those. So that is a discussion that we can have as we go on. So I'd like to stop there and invite questions. Are there any questions concerning what we've covered so far?
Tom, something small.
Yes.
It doesn't relate to most of the things we said. It's navigation systems for persons with visual impairment.
Yes.
I've just seen some document from ITU and how to do the rest and the rest. Despite those mega big commercial things, but there are solutions like that. I haven't seen any anywhere. Audio, I think it's mostly audio navigation systems for persons with
visual impairment.
It could even be for the ones who are deaf, something different. For any solutions to such a challenge or something similar?
Yes, there are systems that are being worked on and designed, especially for the class of people we've mentioned, maybe with visual or audible impairments. What I'd like to do maybe in our discussion tomorrow on smart cities, we can include that into that discussion. And what that will do is that it will give us a wholesome perspective of smart cities, and because the aim of smart cities is basically to make life for the people who live in these cities more fulfilling, less stressful, and easier to move around, and easier to access services, and also lower, excuse me, lower the cost of living for people living in these cities. So there's a lot that, for example, the ITU would recommend, excuse me. But what we can do is that we can cover all that in the session that we've decided to do tomorrow in terms of smart cities. And smart cities will put all this together in terms of the new networks, the 4G, 5G, the LP1, IoTs, automated vehicles, and meeting the UN SDGs in as far as improving the quality of life is concerned. And smart cities combines all these into one session where we'll discuss and look at this and look at the approaches, what is currently happening. Like in Kenya, IBM is really keen in working with the government in as far as smart cities are concerned. So what is our take on that? How can we make sure that we are not used as a guinea pig by some of these organizations when it comes to smart cities? It's not a bad thing, because some of the unique challenges that we face here could easily be addressed if we are used as guinea pigs to test that. But how do we engage with all the parties involved, including the users, including the physically disabled people you mentioned? How do we get their opinion and feedback in as far as smart cities are concerned? You've mentioned the use of audio navigation for people like the blind people. Yes, we can talk of audio navigation right now, and it's very good on paper, but how many people understand English in Kenya? So then there is the issue of inclusion. We might talk of taking the service to them, but they're not using it in such a way that it's beneficial to their lives because maybe of some barriers. How do we level the space so that everyone benefits? So that my uncle or auntie from my rural area comes to Nairobi, and Nairobi is now a smart city, but all the audio prompts, let's assume is visually impaired, all the audio prompts are in English. How will he navigate around? So we see an application of machine learning and teaching these systems our local languages. Yeah. So all that will come into play, and we can touch, not touch, we can actually delve into that in detail in tomorrow's session, if you allow me. Then I'll be able to answer your question effectively.
Tom, just another question.
Yes.
On the use of UAVs, right now they are not yet reaching the automated stage because they are now being piloted by somebody. Is that correct? Or there's direction towards them being now fully on their own?
It's a mix of both. Like in the case for Rwanda, that example is for Rwanda. Those are fully automated with the GPS location of the delivery point. All they need to do in that system is basically enter the coordinates, and sometimes they don't need to. If the system is designed in such a way that if there's a certain hospital requesting for blood, then there could be a system that is able to match or identify that hospital location in the country. And the drone, based on the order it's received, is able to fly there automatically. The ones in Rwanda are not being piloted by someone along the way. The coordinates of the drop-off location is what is required. And of course, that then brings up other questions. Like, yes, it's very easy for those drones. In Rwanda, for example, there are only a specific number of hospitals. But what if you apply the same in parcel delivery? Maybe if you order pizza, is brought via drone. Where will it drop it? So everyone will start having drop-off locations. So whereas Postal Corporation of Kenya is busy trying to see how we can address, use an addressing system for the streets, maybe that might be overtaken by events, where now instead of talking of an addressing system for streets and buildings in Nairobi, we are talking of GPS based or GPS enabled drop-off points for drones, so that if I'm in my house, I register that as my drop-off point, or maybe the compound behind my house. Yeah, and that becomes my delivery address. So you are no longer telling a motorbike guy, ukifika hapo kwa huyo mti piga kona left, alafu uruke bump mbili, hiyo nyumba ya left ndio yangu. Hapana. All you need to do is give a GPS location. And Google is already piloting this because right now it's very difficult for somebody to say I'm at 39.2 degrees east, 1.4 degrees west. That's difficult. So Google has come up with an easier way of GPS locations, and that will be adopted. If you check on Google Maps, you'll see it. That might be adopted to power the coming revolution where we'll use these drones. Some drones are powered, some drones are maneuvered by humans. I give an example of the US military drones because the specific use for those drones is usually maybe a moving target. Maybe whoever they want to target is driving around, yeah? Or it's a specific building and it needs to be a precision strike so that there's no collateral damage. So all that would, of course, need human intervention. But in terms of whether it's powered by humans or it's automatic, it's a mix of both currently, and both work equally well depending on the application. I believe I've answered your question to a great extent.
Yes, you have.
Okay. Any other question? More questions or comments or clarifications needed on what we've covered? So before we close, maybe I just needed to get your feedback in terms of so far the sessions we've had. Are they meeting your expectations in terms of the training? Are they difficult? Are you able to understand them? etc. Because at the end of the day, it will be pointless if we keep on talking about all these systems and we are unable to really follow and understand how they come